If we want to know the range and elevation of a specific land cover type, we can determine that by isolating the land cover of interest and then using the land cover to trim the elevation raster. In this instance, we're going to be looking for the range of elevation in which developed land is found in the Sierra Nevada rasters that we have. To start, we will import the elevation and land use rasters in Python. Next, we will isolate the developed land cover cells, and it's important to note that we have two cell values for developed land, so we will select data with a cell value of either 21 or 23. We can then use the setNull function to combine our developed land raster with the elevation raster and have any cells with a value of 0 in the developed raster removed from the output raster. This results in a raster that does not take up the entire space of the original raster, and it's limited to showing the elevations only within the developed land use areas. So now that we've isolated the elevations we're interested in, we can convert our raster that we've just created with the limited elevation information to an array and then find the minimum and maximum values. As we can see, our elevation range for developed land has a range between 1,887.93 meters and 2,081.78 meters. The final problem we're going to look at in this lab is how to find combinations of data. We're going to do that by looking at the most common combination of land cover and soil type in our study area. We will start by importing the land cover and soil rasters. Next, we will use the combinatorial AND function to combine the data from the land cover and soil type rasters. This will create a new raster with all possible combinations of land cover and soil type. And once we have this combination raster, we can calculate the raster statistics for it. Now we will convert the raster attribute table, or RAT, to a NumPy array. We will first have to specify the pathway to the raster attribute table, and then we can use the table to NumPy array function to create the array. When we use the table to NumPy array function, we will be doing so to find the count or number of each value in the raster. And then in addition to the count, we will also add the land cover and soil values so that we can later see what combination is most common in this area. Once all of this data is combined in a raster attribute table, we can find the most common combination of land cover and soil in two possible ways. The first way is to open the comb attribute table and sort the count in descending order. When we do that, we find the land cover type and soil type that are most common together are 42 and 401 respectively. Or we can use the NumPy sort function to sort the raster attribute table in descending order in the Python window. Both give us the highest cell count of 37,463, with the land use and soil type being 42 and 401 respectively. This represents the most common combination as being forested upland evergreen forest with a rock rubble soil type. You can check these values if you'd like in the land cover and in the soil attribute tables of the rasters.